Okay. Next, we discuss on the example of comparator circuit. So consider we have, this is the op-amp here. The V minus is fixed at the, we supply a fixed DC value, a DC source, plus 6 volt. So this is the fixed value. And we have here, this is your input. So the input is the sinusoidal wave, sinusoidal signal, the sine wave. So the input here, the Vi is a signal that has a very varying voltage over time. Okay, and then this is your V out, your output. And it is stated here the maximum voltage is plus minus 15 volt. So means the maximum is plus 15, the minimum is minus 15. Okay. Okay. Consider this is your input. Your input is a sine wave with the amplitude of 10 volt. So how you can draw the output waveform? So output waveform. So first of all, you need to draw the reference voltage. Okay. What is the reference voltage? In this comparator, you have two input, V plus or V minus. So one of the input will fix at the certain voltage, and another input will be supply will have the input signal. We have the input signal. So the input signal is a variable parameters. Okay. The input port with the fixed value, in this case this is V minus. V minus is the fixed value. So this is your reference. This is your reference. Okay. Or I call it V reference. So 6 volt is your V reference. So you need to draw the vertical line. This is your V reference. So why you need to draw this? Because when you draw this, you can see which part in the signal is the case where the input or is larger than the reference. Okay, so for example, in this part, the smaller part here, okay, this part, so this is where the input is lower than the V reference. Okay, input here. Okay, this is where the V in is lower than V reference. Okay, for this region, this is where your V in is larger than V reference. Okay. This is your V in is larger than V reference. Okay, so now you can identify all the, this is also where the V in is larger than V reference. And then this is where the V in is lower than V reference. This is lower than V reference. Okay. Once you have identified the region, so you can draw the output voltage. You can draw the output voltage. Okay, when V in is lower than V reference, so this means that V in here is a V positive. Yeah, V in is a V positive. Okay, V in is V positive. V positive is lower than V reference is V negative. Okay, when V positive is lower than V negative, V plus is lower than V minus. So we'll have here the minus VCC, or the maximum voltage, the minimum voltage, minus 15. Okay, in this case, when the V in is larger than V reference, the output is a equal to maximum voltage 15 volt. Okay, so you can draw it accordingly. So until the end of the waveform. So from this example, you should notice that the output of this type of op-amp is either plus 15 volt or minus 15 volt. So this is a square wave. Okay. So the output of comparator or in general the nonlinear operation or nonlinear application of op-amp is a square wave. Okay, please remember that so that you can differentiate between the linear application and nonlinear application. Okay, we go to the next example. Okay, in the previous example, we supply a fixed DC source or supply a fixed DC value to one of the input. So in the previous example, we supply 6 volt. Okay. Another way to supply a reference voltage is by having a voltage divider. Okay, voltage divider. For example, we want to supply a positive 6 volt here. So, but we only have a DC source plus 12 volt. So what we can do is we can use two resistors to divide the 12 volt, and then at the end we will have the positive 6 volt here. So this is V minus is using the voltage divider. So this is 10k over 10k plus 10k times 12. So this is 6 volt. Okay, so 6 volt always a fixed value. So the V minus is your reference. So this is your V reference. So this is your V reference. Okay. And then for this circuit, the output is connected to the LED. So let's complete this table. Okay. So when we consider the V in is a negative 6 volt. So V in is negative 6 volt. So in this case, V in is lower than V reference. Okay, V in is lower than V reference. And V in is V plus, or in another way to write it is V plus is lower than V minus. So V minus is 6 volt and V plus is minus 6 volt. So V minus is larger than V plus. So V out is become the minimum value, which is minus 12. So when V out is minus 12, so let's say this is the minus 12. So minus 12, this is the minus value is connected to the anode. So this is a reverse bias. So means that LED is reverse bias. And then this is LED is off. So no light will go out from the LED. Okay, next we consider when V in is 0. So when V in is 0, is still V plus is lower than V minus. Okay, so because V plus is 0, V minus is 6. So V minus is larger than V plus. So in this case also the output voltage is minus 12 volt and LED is off. Okay. Next, when V in is 7, so 7. So in this case, V plus is slightly above the V reference 6. V reference 6, V plus is 7. So in this case, since V plus is larger than V minus, so V out is equal to the maximum. The maximum voltage. So this is plus 12 volt. So plus 12 volt, the positive value is connected to the anode of the LED. So LED is on. Okay, and the last value for the V in 8. So this is the same condition with when the V in is equal to 7. So V out is plus 12 volt and LED is on. Okay, So for the input of comparator, the variable input of the comparator, it can be this DC voltage, the what we call it, the changing of the DC voltage, or it can be a AC signal, which is the sine wave that we have discussed in the previous video. Okay. Oh, over. Okay. So this input here, the input here is connected to the V plus. Okay. So in this configuration, this is a non-inverting op-amp. Non-inverting op-amp. Okay. So you can also have a inverting op-amp. Okay, for inverting op-amp, the input is connected to the V minus, and then the reference is your V plus. So this is the same setup. So this is your V reference is plus 6 volt. Okay, plus 6 volt. So we do the same analysis. Now your V in is 6 minus 6. So when your V in is minus 6, so this is V in is minus 6, and your reference V plus is 6, so V in is lower than V ref. But here your V ref, the V in is your V minus is lower than V plus. So when V plus is larger than V minus, so what happened? We'll have a maximum value 12 volt, and LED is on. Okay, the same situation with when the V in is 0. So when V in is 0, so your V plus is larger than V minus. V minus is lower than V plus, or in other words. Okay, so this is your plus 12 volt, and the LED is on. Okay, when the V in is larger than V reference. Okay, so V in is the V minus, is larger than V plus. So here this is minus 12, and LED is off. The same situation with when the V in is equal to 8. 8 is larger than 6. So 8 is the V minus, and 6 is the V plus. So this is minus 12, and LED is off. Okay. I'd like to summarize on, I'd like to emphasize on the difference between the non-inverting op-amp and inverting op-amp comparator. Okay, the inverting op-amp comparator, one of the difference is where the input, the variable input is applied to. So inverting op-amp comparator, the the variable input, okay, the variable input is applied to the V minus. But for the non-inverting op-amp comparator, so the input is applied to the V plus. So this is the last example for the comparator. So we draw the output. The question is draw the output waveform V out for the given sinusoidal input if V reference is 0, and another case is when the V reference is half of the V peak. Assume that the maximum voltage is plus minus VCC. Okay, so we need to solve the two conditions. Okay, so let's do when the V reference is equal to 0 volt. Okay. When you draw the output waveform of the comparator, it is easier to draw it. You need to draw the input and output not side by side. To draw the input at the up and your output at the bottom of the input. For example, something like this. This is your V in, and then this is your time. You draw your sine wave. Okay, so this is the maximum, the peak value of this one is Vm, and then this is your minus Vm. Okay. So next you need to draw your output voltage. It is easier for you to draw it by having this is your T, and then this is your V out. Okay. And then we know that the output of the op-amp is limited by the plus VCC and minus VCC. So the maximum value is this is the plus VCC, and then this is your minus VCC. So you have prepared the axis and the input waveform. Okay, so next we can do the solution. To do the solution, you need to draw the reference point. Need to draw the reference point. Okay. So let's say the reference point is 0. Okay, so this is the V reference. Okay. So you can see here, this is where this is where your V in is larger than V reference. V in is larger than V reference. This is V in is larger than V reference. Okay. You check again the circuit whether this is inverting or non-inverting amplifier. So V in is at V minus and V reference is at V plus. So please make sure that you take note on that. So V minus is at the V in is at the V minus, and V reference is at V plus. Okay, in this case, when V in is equal to V reference, or we can say the V minus is larger than V plus because V reference is V plus. So this is where the V out is equal to minus VCC. Okay. And then you also have the region where the V in is lower than V reference. This is where the V in is lower than V reference. So in this case, the V out is equal to plus VCC. So the V out is equal to plus VCC. So this is the output of the output waveform. So I write it again. So this is where your V in is lower than V reference, or V in is V minus, V reference is V plus. So that's why you got the plus VCC. Okay, so you can also draw the V when the second case is when the V reference is equal to Vm over 2, half of the amplitude. So again, we draw the input voltage, input waveform here. This is your time. Say now I want to make it 1.5 cycle. So this is your Vm, and then this is your minus Vm. This is your T plus VCC. This is minus CC. Okay. So when you have prepared the the drawing of the input waveform and the axis, so you can draw the reference voltage. Okay, now reference voltage is plus Vm. over 2. So this is the Vref. Okay, Vref. So you can see here the Vref again. The Vref is V plus, and your V in is V minus. So this is your put here V minus. Okay, this is where your V minus is lower than V plus. Okay, let me draw the transition point. So this is the transition point between from the plus VCC to negative VCC. So we start with this one is the V minus minus VCC, and then here your V in is larger than V reference, means that your oh sorry, I done mistake. Okay, so need to correct it. So in this is the region where your V in is lower than V reference. So means that the V reference is larger than your V in. V reference is V plus. So V plus is larger than V minus. So you should get, okay, so this is the mistake. So you should get the plus VCC. And then this in this point, this is where the your V in is larger than V reference. So V minus is larger than V plus. So you got this one here. Okay, and then you continue with the drawing. So this is the drawing here. Connect the line. Okay, so this is your output voltage.